is to impose corporate fines on firms that are found guilty of price fixing or any antitrust activity. This is also historically true of many EU jurisdictions, although that's changing in recent times. But traditionally, this is one sort of set of approaches to antitrust policy. If you look at the US, the Department of Justice in the US has the ability to pursue individual convictions of both civil and criminal nature alongside corporate fines. And the individual penalties in the US can actually be quite severe. So we had a look at data from 2000 to 2009 that's published by the DOJ, and the average jail sentence for individuals that are found guilty of price fixing or any cartel type activity can go up to 19 months, which is pretty bad in terms of lifetime income, but also reputational costs. So it's not a trivial matter. Now, with this in mind, you would expect that these differences in legal regimes expose firm managers to different types of risk, should they choose to form or join a cartel. And if that's true, firms that wish that their managers engage in collusive practices should have to compensate their managers to account for these different degrees of risk. And that's basically the idea of this paper in a nutshell. So the two research questions that we're going to look at is a standard IO question, which is, do antitrust regimes that also prosecute managers have more cartel deterrence power than regimes that only apply corporate fines? So that's the first question. The second question is, do these antitrust regimes distort the managerial labor market in the sense that certain types of contracts, perhaps high-powered contracts, become more prevalent depending on what regime you're operating under? So the way we're going to do this is we're going to examine these questions through a principal-agent framework. So taking the legal regime as given, the principal, who's the shareholder of the firm, offers a contract to the agent, who we take to be the manager or the CEO. It's a linear contract, standard principal-agent theory, with a fixed component and a revenue-based component. If the manager accepts the contract, she plays an infinitely repeated Bertrand game with n-1 firms that also have each of which has its own manager. And in addition to the standard pricing decision, managers have the option to form a cartel. And forming a cartel leads to successful price fixing. We're not really worried how they do that. We're just assuming that once you start a cartel, you're able to coordinate on a price. What we find in terms of equilibrium analysis is that if the antitrust legal regime only issues corporate fines, which is the standard EU case, purely variable contracts don't provide incentives for collusion. The manager requires a fixed component. And in equilibrium, in the optimal contract, shareholders will select a flat wage contract that only has a fixed component. In contrast, in a US-style regime, where the only thing where the antitrust authority prosecutes managers, then a fixed wage contract is never collusive inducing in equilibrium. The optimal contract must always have a variable component and might or might not have a fixed component. In particular, the contract that maximizes cartel stability is a purely variable contract. So you can see that differences in legal approaches to cartel prosecution can lead to very different optimal contracts. But these questions, whether these contracts emerge or not and what are their consequences, is ultimately an empirical question because this is a multiple equilibrium setting. Unfortunately, field data is of limited help for several reasons. The first one is that unfortunately we can't do policy experiments generate legal regime counterfactuals. At least I don't know enough people with sufficient importance to convince them. Detailed managerial compensation data might be difficult to come by in terms of figuring out all the optimal contract information that we would need. And probably most importantly, field data has sample selection bias. So we don't know of we only know cartels that were caught. We only can get data on those types of cartels. We don't know what happened to cartels that never succeeded in forming a cartel or who are still operating right now without detection. So to overcome these issues, we go to the lab to get data from experiments. If you're not an experimentalist, you might wonder, well, is this the same thing as the real world? No, the lab is not a perfect proxy of the real world, but the trade-offs that our subjects face in the lab are internally consistent with our model. And if our model has something to say about the real world, it should also have something to say about the lab. Of course, the stakes are lower, but the trade-offs qualitatively are the same. So we should be able to learn something about how valid our theory is looking at some experimental data. So just a quick summary of our results. Prosecuting managers is more effective than issuing corporate fines at deterring cartel formation. Despite the fact of that, or with that in mind, cartel formation rates were still very, very high throughout. Interestingly, and this is probably the most surprising result of our experiment, is that high-powered contracts didn't lead to more cartel formation than low-powered contracts, particularly in an environment where low-powered contracts shouldn't have any bite. But we'll talk about specifics in a bit. In fact, average prices conditional on cartels being active were pretty much the same across contract types, but actually high-powered contracts led to worse price coordination than low-powered contracts. We also, one of the research questions in this paper is about labor market distortion. So we not only have people playing the role of firm managers, but we also have them play the role of shareholders, selecting contracts. And when selecting contracts, most subjects chose high-powered contracts. Despite the fact that they weren't as successful as theory indicated, most people actually chose high-powered contracts. And most reported doing so in order to incentivize collusion, which is what our theory would predict. Many of them still chose low-powered contracts, and the overwhelming reason, or the majority of people who chose low-powered contracts, stated that they wanted to minimize costs or that they didn't believe that collusion would be sustainable, which is pretty much another equilibrium of our model. So it seems that our model does reasonably well in figuring out what's going on in terms of prediction of the data. Let me give you a couple of slides on how our paper relates to the existing literature before I get down to business. We relate to the literature on antitrust legislation on the likelihood of collusion on the theoretical side. That's a really small and relatively recent literature. There are two papers that we know about that we would like to raise your attention to. The first one is Tabacco et al. In 2013. They look at a chronoduopoly in a strategic delegation framework. So the typical manager maximizes a combination of profits and output. And the authors look at the effect of profit-based fines versus delegation-based fines. And they're really interested in deterrence versus output distortion. And they find that delegation-based fines are output distortive, but they deter cartels better. More closely related to our paper is Aubert 2009, in the sense that this is more of a moral hazard type model. It's actually a double moral hazard problem, in the sense that managers in this model have a choice between two dimensions, two actions: market conduct, which is to price or set quantities in a competitive or collusive fashion, and effort. Effort, in this case, increases productivity, so it lowers production costs. And what they study is the effect of antitrust fines on the optimal trade-off that managers face given a particular incentive contract. And they find that antitrust fines, their effect on optimal behavior of the managers is really dependent on whether the cartel is present or not. They lead the manager to do the right thing in terms of exerting more effort if the market is already competitive, but they have the opposite effect if the market is under a cartel already. We're also contributing on the experimental side to a reasonably growing literature on the effect of communication on cooperation or collusion in indefinitely repeated market games. So there's been a lot of work on the number of firms, as well as the mode and content of communication. We're sort of adding to this literature the role of contracts and moral hazard in terms of pricing decisions to this literature, which no experiment has done so far. In particular, and closer to this literature is a literature that looks at the endogenous emergence of cartels. So this literature tries not to just explain what the effect of communication on pricing or quantity setting in these markets is, because we know that communication helps cooperation, but here we're trying to study when do cartels endogenously emerge. So in an old paper of mine with Hans Theo Norman, we study the effect of N. So does the benefit from cooperation rise or the likelihood of cartels forming go up or down with N? And there's also a paper by Subha Chowdhury and Karsten Krede where they look at this hysteresis effect, post-cartel tacit collusion. It's this idea that once busted, a cartel is less likely to form because firms understand how to coordinate prices tacitly. So if you're calculating damages on cartels, it's really dangerous to look at post-cartel pricing because that's not going to be competitive pricing. There's an interesting, one of their treatments is really interesting because they look at a remedy which would be of managers to a different firm. Whether sending the managers to jail would work in the favor of reducing this effect. We're going to, just as a quick aside, we're going to find very consistent evidence with their findings in terms of post-cartel tacit collusion. But I'll show you that in a minute.
Miguel,
yes?
Miguel, Stephen had a question.
Mm-hmm.
Stephen, would you like to ask?
Yeah, so I was just curious about what kind of communication you feature in your experimental setup, and especially between the shareholders and the managers. Is it just that the shareholders set the contracts for the managers, or is there some sort of discussion?
Right. There's no discussion between shareholders and managers. There's only communication between managers of different firms. In a way, the way we've set up the experiment, and you'll see this in a second, is that it's going to be an intergenerational setup. So people in one session or in one set of sessions are going to determine contracts for people in the future. It's a little bit similar to the advice type experiment. So I set the contracts for someone else. They're not in the same room as me.
Right.
Yeah.
All right. Thanks.
Thanks. So we're also contributing to a very, reasonably small literature on principal agent games. I might be forgetting someone or some papers here, but this literature predominantly works on the idea that fairness might have a role to play in a standard static principal agent game. We're sort of extending the principal agent, experimental principal agent literature to having an indefinitely repeated game being played by the agent, as opposed to a static kind of effort choice type game, which is the case in this literature that you see here. So let me show you the model that basically is the workhorse for the experiment. We have N firms in this model selling a homogeneous good to K consumers under Bertrand competition. There's no production costs. Consumers have an elastic demand. They purchase 1 unit of the good if the price is no larger than P upper bar. Price decisions are made by managers, and the payoff for managers is their wage, which has a fixed component A and a variable component B, which is a function which is multiplied by the revenue of the firm. Managers are symmetric and they're risk averse. They have a standard power utility function. And here are the profits for the firm. Of course, because there is a fixed component and a variable component of the wage in the manager's wage, the standard Bertrand payoffs are slightly different. So we have a loss if the firm does not set the lowest price. And if the firm does set the lowest price, it doesn't capture the entire revenue. It has to give B% of that to the manager and still pay the fixed portion of the salary if that is part of the contract. And if they joint lowest price with M-1 other firms, they share the revenue. So this is pretty standard. Firms interact for an infinite number of periods. And we're going to assume, for simplicity, that managers and shareholders discount the future at the same rate. So what happens in the model? So at the start of the game, at t = 0, the shareholders will offer their manager a contract. The manager can accept the contract or reject it. If the manager accepts, they set prices in every period thereafter. If they reject, they get some outside payoff, W underbar, and that is their utility. And the sum of their discounted payoff or utility flow is given by this expression. So that's their outside option in the infinitely repeated game, or at the start of the negotiation at least. So we have the first proposition, which basically says, if there is a competitive setting without price coordination, the shareholders will basically offer a contract of the form W bar B, where W bar is the fixed component of the wage, and any B that's less than 1. The manager's discounted utility flow is going to be W bar to the alpha, which is the utility from the wage, taken the present value of that. Of course, because this is Bertrand competition, revenues are 0, so the variable component of the wage doesn't matter. And the shareholders' discounted individual profit flow is equal to negative W underbar over 1 minus W. Now, this is interesting because this forces the firm to set super-Nash profits, otherwise in the long run they leave the market, right? You either collude in some sense or set super-Nash profits, or you have to leave the business. So that leads us to collusion. We're going to focus on the sustainability of agreements in which all firms set PC, which stands for collusive price, and PC is going to be somewhere between Nash price, PN, and the maximum price, P upper bar. If all N managers set P upper C, they share all the consumers equally. The revenue from collusion is K times PC over N, which is standard. And we're going to denote U upper C and V upper C as the discounted expected utility to the manager and the shareholder if collusion is happening, or under collusion forever, if you like. Off equilibrium, we're going to assume that all managers adopt grim trigger strategies to punish deviations from the collusive agreement. So if I deviate, if I set a price PD, which is an epsilon below the collusive price, that's going to be followed by Nash pricing forever. And I'm going to denote U upper D and V upper D, the discounted expected utility to the manager and the shareholder if a deviation happens. And I'm going to show you what these parameters are in a second, because that's basically what the optimization problem in the principal agent game is going to be. So the shareholder will offer a contract that induces managers to collude if the following conditions hold, which are the standard principal agent conditions. There's a participation constraint for the shareholders. Their discounted utility from collusion has to be higher than that from Bertrand competition. Pretty standard. The manager's participation constraint, their discounted utility from collusion has to be higher than that from rejecting the contract. They need to want to collude. And the discounted utility from collusion has to be higher than that from deviation, which is an incentive compatibility constraint. So formally speaking, this is the optimization problem that we're solving. And all that's left to do is to calculate VC, UC, and UD. And for that, we need to understand the antitrust authority. So we're going to assume that there exists some antitrust authority that monitors this market with some probability, and if they detect a cartel, they're going to impose a fine. We're going to consider two types of fines: a firm revenue-based fine, which is modeled after the EU example that I gave you earlier, and a manager prosecution fine, which is inspired. It's an extreme version of the US case, where the manager bears all the brunt of the prosecution. We're going to assume, for comparability and simplicity, that if the cartel is detected by the antitrust authority today, it can restart tomorrow. We're going to assume that recidivism isn't penalized any harsher than first-time offenses. It's not a very realistic assumption, but it simplifies the analysis a lot. We're also making a a simplification assumption that the antitrust authority doesn't have any dynamic auditing strategies. It's just a standard IID probability of detection. And we're going to assume that there's no leniency policies. The fines are levied on everybody who was part of the cartel. So deviators as well as people who are setting the collusive part. This is just to make the analysis simple and tractable. So in the case of a firm revenue fine, we're going to assume that the fine is going to be 1 minus F times the revenue of the firm under the cartel. So if in a given period the cartel is undetected, and that happens with probability 1 minus tau, the profit for the firm is going to be equal to RC, the revenue from collusion, minus the wage that they pay to the manager. With some probability tau, the cartel is detected, and the firm can only capture F% of the revenue. The rest goes to the antitrust authority, but the manager's wage also gets affected by the fine. So both manager and the firm are exposed to risk in this context. So let's calculate discounted flows of utility. So if managers coordinate prices in all periods, here is the discounted flow of utility to the shareholders. Excuse me. So in a given period, the cartel might not be caught, and this is the profit from no fine, plus the discounted sum of profits in the future. Or the cartel is detected, they pay the profit from paying the fine, plus the discounted sum of utilities from the future, given that they can restart the cartel tomorrow. In the case of the manager, the same applies. With some probability 1 minus tau, the cartel is undetected. The manager gets the utility from the full wage, plus the discounted sum of utilities in the future. With some probability, they pay, they receive a smaller wage because of the fine. If they deviate from the collusive agreement, the payoffs are slightly different. They get some short-run benefit from deviation, which could be multiplied by the fine, depending on whether they're caught or not. But then they play Nash forever, and that's the discounted sum of profits from playing Nash forever. So we plug this into the optimization problem. I won't bore you with the math. I'll just give you the proposition. Under the revenue-based fine regime, shareholders optimally offer fixed wage contracts. So there's no variable component to the wage. So what's the intuition? The intuition is that because the managers are risk averse, a fixed wage contract is the only contract that satisfies their participation constraint. With that in mind, W is independent of revenue. And in that case, the incentive compatibility constraint is satisfied with equality. In other words, the manager is going to be indifferent between colluding and not colluding. And that leaves us with what fixed proportion, what is A equal to? Well, in our model, the shareholders have all the bargaining power. So they set A equals to the outside option for the manager. So again, in this case, managers are indifferent between colluding and not colluding. We're going to assume that in case of indifference, they choose to collude. Although the other equilibrium is also possible, in which no collusion happens. This basically follows standard intuition from contract theory. If you have two parties that are exposed to risk, principal and the agent, but the principal is risk neutral when the risk agent is risk averse, the risk neutral principal should really bear all the risk in the optimal contract. So this is pretty much standard principal agency applied to our set. So that's basically the first case. Let me go to the other extreme case, which is the manager prosecution approach. We're going to model prosecution as a direct utility cost through the remuneration of the manager. We're going to assume that going to jail affects your salary, but it also affects your lifetime earnings and through reputational consequences. So we're going to assume that that is captured by losing a fraction of your total wage or the utility from your total wage. So not only on the variable part of your contract, but also on the fixed portion of your contract. So here's what it looks like. If the cartel is undetected, the manager gets their full wage. This is the revenue from perfect collusion. If the cartel is detected, that wage is multiplied by some parameter less than 1. So if we're colluding in this regime, the discounted sum of utilities for the manager is going to be equal to the following. With some probability the cartel is detected, the wage for the manager goes down by a factor of phi, plus this discounted utility from the future. With some probability the cartel is undetected, and this is the discounted sum of utilities in that case. This simplifies to this expression, which will going to be useful in a moment. And little phi here, you can interpret this as the net of fine share of utility that you expect to receive in every period if you're the manager. So far pretty standard, just algebra. If they deviate, the payoffs are similar to last time. The managers can either get their full wage if the cartel is undetected, or their relative share times the fine. And then they play Nash forever, so this is their discounted utility from playing Nash forever. What's interesting is that in this case, the shareholder doesn't get affected by the fine at all. Their discounted utility flow under collusion is just going to be the present value of the profit that they get from collusion, which means that V of V tilde C is strictly decreasing in both parameters of the contract. Now this means, of course, that the shareholders will offer the lowest A and B such that the manager is indifferent between accepting and rejecting the contract. That's given by this equation here, where this is the discounted utility from collusion and this is the outside option. I can solve this for A, and you notice immediately that there's a really nice trade-off between A and B. But more importantly, if I plug this value here into my shareholders' expected discounted utility flow equation, I get the following expression, which is really neat, and importantly is completely independent of A and B, which means that no matter what contract the shareholder offers to the agent or to the manager, their discounted utility flow is going to be the same under any contract that the manager accepts. Of course, setting different A/B parameters that are acceptable to the manager has consequences. If I offer a fixed wage to the manager, that means that I can offer a lower B, of course, and that decreases the deviation gain to the manager, which basically means collusion becomes easier. On the other hand, having a positive A means that the manager gets a positive utility on the punishment path. Therefore, deviation becomes more attractive. So there are going to be these two opposing effects on the likelihood, or on the incentive to collude, I should say, and that's going to matter. So the proposition that we get once we solve for the optimization problem is the following. You get three interesting results. Under a manager salary fine regime, a fixed wage contract never induces managers to coordinate prices. And I'll show you some intuition as to why that's the case. But if managers are sufficiently patient, the purely variable contract, which is 0 on the fixed component and this very ugly expression for B, is going to be optimal in the sense that it maximizes the difference between expected collusion utility and deviation utility. If managers are not sufficiently patient, then there's no contract that provides them incentives to coordinate prices, and the discount rate, the minimum discount rate that sustains collusion, is equal to this. It's, as you would expect, a function of the number of firms in the market and the risk aversion parameter. So let me give you some intuition for the first part of the proposition. Suppose that we would offer a fixed wage contract to the manager. Well, along the collusive path, the manager receives A if the cartel is undetected, but phi times A, which is smaller than A by definition, if the cartel is detected. On the other hand, if the manager deviates, he still gets A, but importantly, he can only get fined in that period in which he deviates. In any period after that, the manager can never be fined, which means that there's a strict incentive for the manager to deviate right away, because it reduces the likelihood that they're going to be fined at any given point in the future. So collusion cannot be sustained in this particular regime with a fixed wage contract. Now, I mentioned that the purely variable contract was optimal. I should note that it's not the only contract that's incentive compatible in terms of collusion. There's going to be a continuum of contracts with a positive fixed component and a variable component that satisfy this particular expression here, which is derived from the outside option being equal to the collusion utilities or discounted utilities. But importantly, like I said, the purely variable contract maximizes the difference between the expected payoff from colluding and the expected payoff from deviating. So it should be the contract that makes collusion most sustainable in that sense. So any questions? I went through the theory very quickly because I need some time for the experiment, but happy to take questions. Okay. Feel free to interrupt if you have any questions at any time. So I've shown you a really rich model. Lots of things are going on. There are lots of testable hypotheses that we can go for, but we couldn't really do one design that would test all of them. So we're going to focus on what we think is the most interesting question, which is the idea of incentive compatibility of contracts. We're going to ask two questions. Are manager salary fines more effective at deterring cartels than firm revenue penalties? So is one environment better than the other one? And the second one, we're going to take advantage of our particularly stark prediction that in one regime, variable or high-powered contracts, which are contracts with a very high B parameter, are necessary and sufficient, whereas in the other environment, they're neither necessary nor sufficient. So are we going to see this in the data? Are high-powered contracts more likely to incentivize managers? And does that vary by regime? And the last question is, are high-powered contracts more likely to be selected by shareholders? And again, does that vary with regime or not? So with that in mind, this is our experiment. We had subjects playing the role of firm manager. This is our core game, if you like. The market was made up of 24 computerized consumers, and each consumer demanded 1 unit of the good if the price was no larger than 10. There were 4 firms in the market. There are no production costs. Managers picked prices from a grid that ranged from 0 to 10 in steps of 0.01. And the market was equally shared among firms to set the lowest price. So pretty easy, just like our basic model. Our model is a model of an infinitely repeated game. So the way to make that, or to get close to that reality in the lab, we need to have a probability of discontinuation. So we introduce uncertainty about when each market will end. So at the end of every period, subjects were told that there's a 1 in 10 chance the market would end. So that introduces a discount rate of 0.9. So it was literally explained as the computer will draw a number between 1 and 10 at random. If the number is 10, the market stops. If the number is 1 through 9, the market continues for another round, and then it does it again, always from period 1 onwards. So just some issues around practicality. So each session would have 3 markets taking place at the same time. So there were 12 people per session. And this probability of continuation affected every market at the same time, in the same way, I should say. 2 reasons for this. One, we wanted every super game to have the same duration. And because once each super game ended, we wanted to reallocate people to different markets. So if 4 people would interact within a market for the duration of that market, but we didn't want reputation effects that happened or that were created in market 1 to carry over to market 2. So after market 1 ended, we scrambled the composition of the market and they started again, 2 and so on. So for that, we needed all the markets to start and finish at the same time. So in that sense, and to make comparability across sessions, we basically pre-generated the random sequence of draws to make our life easier in a way. So we're interested in high-powered contracts versus contracts. So we offered 2 contracts to our subjects. A high-powered contract that had a fixed component of 30 and a variable component of 20% of revenue, and a low-powered contract that had a fixed component of 30 and a variable component of 2%. And all managers in a given market had the same contract. So we didn't want some managers to have high-powered contracts competing against people with low-powered contracts. So in a market, everyone had the same contract and everyone knew that. So each session had 4 markets. The reason why we had 4 markets is that given our probability of continuation, the expected duration of each market was about 10 rounds, 10 periods. So 4 markets gives us 40 periods, which gets us enough data in a session, but is not long. No, not too long. There's always a fear that people who are sitting down and doing these experiments might get tired, they might get bored. We want them to be focused on the decision, so therefore we opted to impose a cap on the duration of the session and work out how many super games we can fit within that time frame. Because we're offering 2 different contracts and each individual is going to be exposed to each contract, the order might matter. The order in which we present contracts might matter. So in half of our sessions, we had high-powered contract, followed by low-powered contract, followed by high-powered contract, followed by low-powered contract, and the reverse order in the other sessions, just to be sure that any result might not be driven by some sort of order effect. So here's our design. So we have two dimensions in our design. The first one is contract type, which I've already explained. The other is going to be the legal regime, which is outlined here. So no chat is our control condition, if you like, or control number one. And the no chat condition worked exactly as I've explained to you. Subjects came into the lab, they read the instructions, and they started setting prices. They would set price in round one, find out profits, set price in round two, find out profits, and so on. The market ends, they get reallocated to a new market, they start again. And they do this 4 times. In the chat no law condition, at the start of the second round, and from the second round of each market onwards, subjects were able, they saw a button on the screen before they set their prices. And they were told that if everybody in the market pressed that button on that round, a chat box would open and they would be able to talk or to send messages to each other in a chat box for 30 seconds. There would be no restriction on what they can say. They couldn't insult each other, they couldn't threaten each other, and they couldn't identify each other. But that's pretty standard in the literature, so we're not being creative here. But there would be no risk whatsoever from communication. So there was no mention of any antitrust authority or any penalty from chatting. So that's, in a sense, a control in which communication is riskless. The main treatments are Chat US and Chat EU. So these were exactly like Chat No Law. So we told our subjects there's going to be this button. If you press it before, I should say, once the chat box is open in Chat No Law, it stays open forever. So you'd always communicate prior to your pricing decisions until the end of the market. Sorry. In Chat US and Chat EU, they were told the very same information in Chat No Law. On top of that, we told them there's going to be an antitrust authority, there's going to be an authority that will monitor your market with some probability. And if they monitor your market and your market has a chat box open, you'll pay a fine. And the chat box will close. Once the chat box is closed, you can reopen it, but only next round, not in the current round. And other than that, the game was exactly the same. And these are the numbers of sessions, markets, and pricing decisions that we have for each treatment. So in the Chat US, Chat EU conditions, the probability of detection was 20%. We sort of calibrated it such that it would be reasonable to expect to be at least one period in which you're going to be detected. Probably, if I could go back, I would have had a higher probability, but I'll show you why in a minute. And the fine in Chat US was 35% of the total wage. In Chat EU, it was only a percentage of the variable component of the wage. At the end of the experiment, at the end of each session, we measured risk aversion. We used the standard measure, Gnesian Potters. Our sample were 576 undergraduate students from the University of Exeter across a bunch of fields. Sessions lasted for an hour. Subject got paid £13 for that average hour, but notice that there was a lot of scope for gains from collusion. This is the average payment from this session, pretty much, or this session accounts a lot for this, whereas this session accounts a lot for that. So these two sessions are somewhere in the middle. So there's a lot of gains from collusion in this game. So before I get down to results, I need to talk about contract choice. And to talk about contract choice, I need to explain a particular feature of our design. So our design actually had 2 sets of sessions. This goes back to Stephen's question earlier about shareholders and managers. So phase 1 sessions took place exactly as I've explained. So people would go into the session, they would play a pricing game once, super game once, another super game, the 4th super game, The experiment would then be over. We tell them this is how much you're going to earn in this experiment. But by the way, we would like you to make an extra choice. We told subjects we're going to run some sessions in the future, and they're going to look exactly like the session that you've participated in today, except that you're going to be the shareholder or the firm owner of one of those firms. And we would like you to select the contract you would like to give to the manager of that firm in the future. So these people, at the end of their experiment, were selecting contracts for someone who will play in a future session. And in that session experiment, in the instructions for this session, we actually said this. Oh, and by the way, any profits that you make in this session will revert to you. And that's what we explained to these people. People who played in phase 2 sessions were told pretty much the same instructions about the game and about how it worked, except that they were told profits will go to a subject, to another participant that did this experiment a week ago. So in that sense, contracts here are going to be endogenous, whereas here they're set by us, they're exogenous. And this is the reason for phase 2 was predominantly so that we wouldn't deceive participants in this choice. We had to make this a real choice. So in a sense, we were forced to run phase 2, but we get an extra behavioral hypothesis for free, which is the idea of reciprocity between managers in these sessions and the shareholders here. But I'll explain that in 3 slides. So what about hypotheses? We have the following ones. So here's a hypothesis about likelihood of forming cartels, highest when there's no risk, and then followed by chat EU, followed by chat US, followed by no chat. This is because low-powered contracts, the way we've selected them, this does not satisfy the incentive compatibility constraint for the manager, so you shouldn't see collusion taking place in chat US. With high-powered contracts, all of these conditions satisfy the incentive compatibility constraint. Therefore, you should see collusion in all of these, but of course, never in no chat. And this is the same statement put in a different hypothesis. High-powered contracts should matter in chat US, but not in chat EU. In terms of cartel prices, this is more of a housekeeping hypothesis. Conditional on agreeing to communicate, managers will coordinate on the maximum price, so price of 10, and that's regardless of the treatment. The basic idea is around payoff dominance. So 10 is the joint profit maximum. And it's also a focal point. It's the highest price you can set in the grid. So we assume that that's going to be the obvious choice for coordination. The fourth hypothesis has to do with labor markets, contract choice. So the likelihood of firm owners choosing the high-powered contract should be higher in chat US than in any other treatment. And that's precisely because chat US is the only treatment in which high-powered contracts are required to satisfy the incentive compatibility constraint for the managers. In all of these other treatments, either you don't need to incentivize collusion, or low-powered contracts are enough. So you don't need to select a more expensive contract. The final hypothesis, which is more of a freebie from the design, is the idea of reciprocity in contract choice. So an alternative to our principal agent model is an idea of reciprocity, which is widely documented in the behavioral literature, that says that in a lot of firm environments, firms operate in a gift exchange manner. So the firm offers higher than equilibrium wages to workers, and workers reciprocate by producing more or exerting more effort than in equilibrium. In our case, because we have humans offering contract to other humans, we should see high-powered contracts being more effective in phase 2 than in phase 1, regardless of the treatment. And that's because of this gift exchange hypothesis. I hope that makes sense. I'm now can show you some data. So let me show you some data on cartel formation rates. So what you're seeing here is the relative frequency or the likelihood of at least one cartel being formed in the during the existence of a market. So by definition, no chat never saw any markets, any cartels being formed because they didn't have the option. So what we're seeing here is market level data. We're looking at all market, each market throughout the duration of its existence. And what you see is what you have here is low-powered contracts on the left, high-powered contracts on the right, phase 1 data on top, phase 2 data in the bottom. So I would like to focus your attention to the top row, which is phase 1. And let's start with low-powered contracts. So our theory predicts that so you have on the x-axis no chat, chat no law, chat EU, and chat US. So we're increasing the risk to managers as we move from left to right. And in fact, the relative frequency declines. So the probability of forming at least one cartel goes down as you move from chat no law to chat EU to chat US. This holds with equality. These two numbers are the same, or are not statistically significantly different. Neither are these, but we do see a significant difference between chat US and chat EU and chat no law, as well as a similar significant difference between chat US and the other two conditions. So this is reasonably consistent with the model. In phase 2, the data looks reasonably similar. The only difference is that we see more collusion in chat US under both low-powered contracts and high-powered contracts. So we see the same ordering, roughly, but these two averages are not significantly different, and neither are these two. So that's our first result. Our theory predicts contract formation pretty well. The highest rates of contract formation are in chat no law, followed by chat EU, followed by chat US, and by construction, followed by no chat. And this is roughly the same in phase 2, with some inequalities not being strict in different places. Now let's look at hypotheses, at the hypotheses around contract type. So now I want to look at high-powered contracts versus low-powered contracts, fixing the treatment. So now I'm comparing this frequency with this frequency, and likewise for the other treatments. And as you can see, if you eyeball this chart, you basically realize that this number is not significantly different from that number, and the same is true for every single treatment in both phases. So high-powered contracts really don't make a difference on cartel formation. This could be because we're seeing huge rates of cartel formation, and that's why I made that comment about the probability of detection. But that's just the way the data is. You only know until you run the experiment. So that's our second result. The likelihood of forming cartels is unaffected by contract type. The last thing that I want to talk about is this reciprocity idea that says that phase 2, high-powered contracts in phase 2 should lead to more cartels than in phase 1. Because in this phase, a high-powered contract can be interpreted as a generous offer. The manager sees, oh, okay, I could have gotten an X contract, but a low-powered contract, but the shareholder actually gave me a high-powered contract, so I'm going to be nice. The evidence is, if anything, mixed, although there are no significant differences. So you see more cartels in phase 2 under chat no law, than in phase one, but the reverse in chat EU, even though these differences are not significant, but nominally you see a nominal difference. And the reverse again in chat US. You don't see a particularly consistent pattern of behavior, and that's basically what we find here. High-powered contracts don't lead to more cartel formation in phase two. So we don't have much evidence for reciprocity. So far, I've shown you market level data, but remember that individual managers had the option to click on the button. So we might see cases where 3 out of 4 managers clicked on the button, but one person didn't, and then we don't see a cartel. So it's interesting to look at decisions to form a cartel. So, and that's what this regression does. So the dependent variable on this regression is a dummy that equals 1 if manager J in market I in round T pressed the button to open the chat box when he had that button to press, when he had the option to. The first regression basically only takes into account the treatment variables in our experiment, so the contract type and the type of contract. The omitted category here is chat no law. And these are marginal effects. So what you see here is that chat US, individuals in chat US were significantly less likely to vote or to choose to form a cartel relative to chat no law. And the chat EU, the same effect, but marginally significant. But interestingly, no effect of high-powered contracts. The coefficients are really small and they're not statistically significant. The second regression adds to these regressors 3 types of variables. The first one, which I call caught, is a dummy variable that equals 1 if a cartel had been busted before you have to make your decision to start a new one. So this captures the effect of reformation of cartels. And the coefficient on caught is negative and highly significant, which again, like I said earlier in the presentation, confirms the finding by Chowdhury and Kreda that once a cartel is busted, it's less likely to reform. The period variable is essentially a linear time trend. It sort of captures learning that can happen within a market. There's no learning happening here in terms of choosing to form a cartel. But the dummies on the super games are positive and highly significant. And this basically means that the more super games I play, the more I realize that forming cartels is a good idea, or that I want to form more cartels, which confirms some evidence. If you're interested in this and if you want to run these experiments, Dalbo and Frechette talk about the need to learn how to play the super game. It's not necessary only to learn how to play a stage game. If you're looking at behavior in an infinitely repeated game, you need to learn how to play the super game as well. And this is what we're finding in our data as well.
Miguel,
finally, yeah?
I have a question.
Sure.
Okay.
Yes, go ahead.
Oh, yes. So you explain about these super game variables, right? So
Yep.
Does it explain about the cartel stability as well?
It would suggest that cartel stability. No, because cartel stability is a function of audits and of prices, right? So in our design, once the chat box is open, it's open forever until it's detected. So in a way, I can't quit a cartel.
Okay.
That's probably a flaw in our design,
Mm-hmm.
but we thought that the experiment was already complicated and we didn't want to have too many decisions. I mean, we could have opted for them to open the chat box every time, but we think that would have biased our results in a different direction. So we just followed the convention in the literature, which is once a cartel is open, it's open.
Okay, thank you.
No worries, but I will show you average prices, which will tell you a little bit about that, but I won't be able to tell you about super game. Hang on, give me a second. Give me a second because I think I can answer that question. So just to wrap up, the third specification includes risk aversion, and risk aversion is negative and highly significant, which basically suggests that the more risk averse a manager is, the less likely they want to enter into a cartel. This is phase 1 data. I'm not going to show you phase 2 data because it's pretty much similar, although the only thing that's different is the risk aversion effect, which is same sign, but significance is not there. So I'm not going to sell my house or bet my house on the risk aversion effect. But this is the result. And I think I'll go ahead in the interest of time. And sorry, Ju Young, to your question, this is your answer to your question about cartel stability. So what we have here is a regression on price coordination. So this regression has its market level data, and this PV equals 1 if every manager in the market selected the same price, and 0 otherwise. And I can tell you that 99% of these cases are P equals 10. So what do we find? We find that in chat US, so the omitted category here is chat no law. We see that chat US leads to much worse price coordination than chat no law. And surprisingly, that high-powered contracts also lead to worse price coordination, with the exception of chat US. Now, to your question about super games, we see positive and significant coefficients in the super games as well, and they're actually getting bigger. So to answer your question, cartels are becoming more stable as firms learn how to play the super game. So the phase 2 dummies seems like phase 2 in general is a little bit worse on price coordination, with the except of chat US, but the coefficients are not systematic, so I don't have much to say about phase 2 data as being different to phase 1 in any meaningful way. So that's our basic results from parse coordination data. And let me, because I am running out of time, let me go straight into average prices. What you have here are average prices that are conditional on a number of things. So on the left, you have low-powered contracts. On the right, you have high-powered contracts. Now, the dots, which are predominantly at the bottom of each diagram, so you have the treatments on the x-axis and price on the y-axis. Dots or circles are average prices conditional on a chat box being closed. So these were periods in which managers were not talking. Diamonds, on the other hand, are average prices conditional on a chat box being open. So gray dots or gray circles and diamonds are phase 1 data. Black diamonds and black dots are phase 2 data. A couple of things to note, and this is confirming a wealth of data from tons of experiments for lots of time. If you communicate, you can set higher prices, regardless of the treatment. That's not a shock. It's good to see that we're replicating a ton of data that exists in the past. Another interesting thing that we're replicating is Chowdhury and Creda, and to some extent Fonseca and Norman, which is this idea of post-cartel tacit collusion. To see why, have a look at this average price. So this is the average price set in no chat. These people were never able to open a chat box. So all of these periods, or all of these cases are cases where they've never had any chat experience. On the other hand, all of these cases include periods before the first cartel was created, but also after the first cartel was created. And you can see that average prices are higher. And this can only be accounted for by the experience of communication. So we're basically replicating this post-cartel tacit collusion result, and notice that the effect is reasonably large. It's about a 200 to 300% change in all conditions. This will vary according to phase, but it's a pretty robust finding. So what else do I have to, the last thing that I want to show you is this reciprocity idea. Now, reciprocity says the manager in phase, so I'm a manager in phase 2, I received a high-powered contract. I'm really happy because the shareholder has been nice to me. I should reciprocate with higher prices. Whereas in phase 1, our subjects were basically given contracts by me and my co-authors, and they really don't care about me. So you should see higher prices in phase 2, which are black diamonds, that rather than phase 1, which are gray diamonds. You see some evidence of this in these two cases, but not in chat US. You see some evidence that they are coordinating better, but sorry, no, sorry. Yes, sorry, I confused myself for a minute. So you do see some evidence of reciprocity to the extent that you see a significant difference between these two treatments. This is marginally significant, this is highly significant. This, of course, is not significant. So you see some mixed evidence of reciprocity motives on the part of managers. So that's all I have to say, unless you have any questions. The last thing that I want to show you is contract choices. So remember, at the end of phase 1, managers turned into shareholders and they were able to offer contracts to future managers, and they would get some money out of that. Our model predicts that this is the condition where it matters, because this high-powered contracts satisfy the incentive compatibility constraint in this condition, but they're not necessary in these treatments. In this treatment, you wouldn't be able to price above marginal cost by much. In this case, you don't need any incentives because chatting is free. And in this case, you should do well enough with a low-powered contract. What you see is different. You see most cases, about 60% of managers in these three treatments chose the high-powered contract. This is the frequency of high-powered contract choice. In the chat no law condition, it's about 35%. This is surprising. We would expect much lower rates of, particularly here, if I'm honest. So we were a little bit surprised. We see some evidence that the incentive compatibility constraint works, but not a lot. We were hoping for less contract choices here. So to figure why this is happening, we went to the post-experimental survey. So if you've never run an experiment before, it's pretty common for researchers to ask a bunch of questions after the experiment, and one of them typically is, why did you do what you did? Why did you make your choices? What was your rationale? In our case, we had two of these questions. One question that had to do with how did you price? How did you choose to talk? And for phase 1 subjects, we also had a question, why did you choose the contract that you chose? So we went back into the data and we coded the open responses so they could type whatever they wanted, and we classified those responses that are completely unincentivized. So I don't know if they're telling the truth or not, but it was an interesting exercise to see what justifications they had. So this is what I'm going to show you very briefly. So the first category that emerged from reading the responses was self-interest, which is good if you're an economic theorist. And these are typical responses. More profit for me, I'm greedy, this makes more money if I choose the low-powered contract, great. The second motive that sort of emerged was an incentive compatibility constraint, or giving incentives to collude. So here's a typical response. I realized that if managers were acting rationally, then my profit would be higher if the contract has 20% of revenue in, as it should encourage collusion. This person clearly understands principal agent theory, as does the person who has the quote from below. So these are representative quotes. We had lots and lots of them. I'm just showing you some to give you a flavor. We also had an interesting category where people actually talked about disincentivizing defection. So they were not worried about sustaining collusion, they were worried about defecting, and they basically argued for low-powered contracts as giving less incentive to deviate. So here's a quote that illustrates that. With a lower variable component, people tended to go rogue less, as it paid off much less and so wasn't worth it. So everyone stuck to putting 10. So very different type of frame of mind. Whether it makes sense game theoretically, I'm not sure, but there it is. The last one that I want to discuss at some length is altruism. So this emerged quite a lot. A lot of people expressed concern for the welfare. 20% is the nice choice. Give the other manager an opportunity to earn as much as possible. Feels ethical, that sort of stuff. Notice, however, that concern for the manager doesn't mean reciprocity. These people are not saying, I'm being nice because I expect other people, I expect them to be nice back to me. We had a separate category for that. So let me show you a tabulation of how these categories correlate or associate with contract choice. So you can see that the self-interest motive is predominantly associated with low-powered contracts, about 4-to-1. And that accounted for the most of our subjects actually justified their choices on the basis of their own self-interest. On the other hand, people whose responses indicated some incentive compatibility constraint rationale, there were predominantly people who chose high-powered contracts. We could match responses to their actual behavior. It's not that we're asking them what contract they chose. We could actually check. On the other hand, people who were worried about defection incentives, 4-to-1 roughly, chose the low-powered contract. Those who expressed altruistic justifications pretty much all selected the high-powered contract. And notice that all of these, I'm not entirely sure about this category, to be honest with you, but all of these have some theoretical justification. They make sense. We could incorporate altruism concerns in our model, and that would explain high-powered contracts trivially. There were a few people who had justifications about, oh, you know, I made more money when I had this particular contract, so I picked it. Not a very theoretically insightful one. Some people mentioned risk, which was difficult to pin down because it's not their risk aversion, it should be the manager's risk aversion. But interestingly, reciprocity was never mentioned. And it was mentioned by someone who picked the low-powered contract, which is completely inconsistent with what we would expect. And then there was a bunch of people who we couldn't code. So what's interesting here is that the motives that firm managers, the firm owners assign to their contract choices are pretty consistent with economic theory, either in a standard sense or in a behavioral sense, except reciprocity. Reciprocity doesn't seem to be a valid motive. And those people who cite self-interest and chose low-powered contracts, well, that's fine. That's an equilibrium. So I'm not too worried about these people. I'm perhaps worried about these, but I don't know what to make of that, to be quite honest. So let me wrap up. This paper extends our understanding of theory and behavior in a repeated Bertrand setting in two complementary directions. On one hand, we framed the Bertrand game as part of a more general game, where manager and shareholder incentives are not necessarily aligned, and the shareholder profit motive can actually lead to very particular contract choices. And those contract choices are going to be framed or shaped by the role of antitrust legislation. So we find this interesting case that in order to curb collusion, you actually create, by fining or prosecuting managers, you're actually creating the incentives to shareholders to offer really high-powered contracts. And we study this in the lab. We have, I think, a novel experimental setting for the IO case in any case, but our environment, despite being novel, replicates a lot of regularities that exist out there in the literature, which I summarize here for you, which I've already mentioned, so I won't trouble you with more of that. I think the interesting case that we weren't expecting was that high-powered contracts were not more effective at promoting cartel formation. I think if you ask me to put my finger on why, there are quite a few possibilities. I think risk aversion is a possibility. Maybe managers were more risk averse than we thought that they were, or loss averse. Loss aversion could be a reason, but it exists outside of our model, so I'm not sure what would happen if we impose loss aversion. It could be that their horizon, their discount rate was different from what the experimental parameters impose. So maybe they discount the future a lot more. And I think that that's an interesting kind of, so in a sense, maybe our high-powered contract wasn't high-powered enough. I think we also have a problem with a ceiling effect. I think we were seeing a lot of cartels in the first place. So I think there's a really interesting scope to understand the interactions between incentive design and behavior in these infinitely repeated environments. And I think that's something really interesting to look forward to. And I think that's me. So unless do you have any questions, any comments, feel free. It's relatively out of the oven, this paper, so any comments are very helpful.
Oh yeah, Miguel, thank you very much. Yeah, we have around 8 minutes, so if you have a question, feel free to ask him. Oh, so Miguel, actually, I have one question. So when you talk about the in-chat US case, you said that there is no difference between phase 1 and 2 for high-powered contract, right?
Mm-hmm. In prices wise?
So you show one that, yeah, here.
Yeah.
So you said that when we look at the chat US for this high-powered contract, so there is no difference, right?
Yeah, in average prices when.
Yeah, average. So it might be because of the risk averse, right? Because for me, because I will be happy to be low-powered contracts.
Right. That's
right.
true, but it's interesting that the degree of risk exposure on these two phases is the same. So these guys are faced with the same risk profile, the same type of lottery, if you like. So it's surprising that there is a difference here, and here they face no risk, and you see higher prices in phase 2 than in phase 1. But somehow here, I mean, look, it could be, we have a lot of data. I think this experiment is reasonably powered, but at the same time, we have a limited amount of markets. So we have, let me just go back to the experimental design because I don't remember exactly the numbers, but I think we had, So all I'm trying, yeah. So it might be that we needed more power, or I don't know. So we had 72 markets. No, I think we were pretty well powered. I'll take that back. So these are. I think this is one of the advantages of our design, is that we happen to have a lot of data to draw from. So yeah, it's interesting. It could be risk. It could be. Yeah, it's.
No, I'm just curious if this, in this case, so somebody chose my contract, right? Mm-hmm. So in phase 2, right? In phase 1, so if I could choose contract between high powered and low powered, do you think you will still have the same result?
Could you say that again?
No. So what I'm saying is, so if the manager can choose a contract between high-powered one and low-powered one, do you think you will still have the same result?
I think there you might see a selection effect that would lead to much more cartel formation by those who choose high-powered contracts. There, I think you would see a dramatic effect. Completely driven by selection, which is similar to this literature that sort of explains why the gender effects in competition. There's this, Armin Falk and other people, they have these experiments where you can pick your compensation regime. I don't know if you're familiar with that literature, and they find that men choose contests or competitive compensation, whereas females tend to pick flat wage contracts. So here you'd see a similar effect. I'm not drawing a, well, I am drawing a parallel. So ignoring the gender argument, the risk aversion story would certainly say that the risk seekers would want to pick the high-powered contract for sure. In a sense, that would be an interesting avenue of research, is to see, do risk-seeking CEOs choose to work in environments where firms want to give them these types of high-powered contracts? Again, it's something that we can't see in the data in the real world, but it would be something that the model would predict. Yeah. I don't know if you answered your question.
Yeah, that is good. Yeah, thank you. And Minyoung had one question.
Okay.
Minyoung.
Hi, I think that's really interesting paper and idea. I don't know if I missed something. So how is the risk of being caught reflected in the experimental details? So, experimental design, sorry.
Right. So the experimental, so in these treatments here, in chat-EU and chat-US, we told subjects that in every round, there's a 20% chance that an authority will monitor your market. And that's independent of whatever's happening in your market. It's every period, 20% chance that your market will be monitored. If the chat box is not open, nothing happens. So life goes on as usual. If the chat box is open, then a fine is levied on every person in the market. Does that make sense?
Yeah. Okay. So because you are imposing the same risk of being caught, whether it's a high power contract being offered or a low powered contract being offered, right?
Correct.
I was just wondering that whether the effect of high powered versus low powered contract on the incentives to collude, whether that would differ based on depending on the risk of being caught. So in other words, if the risk of being caught changes, I wonder if the effect would be different.
Possibly, but then you'd have to have a game being played by the authority and the managers. So that would, to get at what you're, if I understood your question correctly, you would need the antitrust authority to say, my probability of audit is going to be different depending on what contracts I see. But in this case, where the model explicitly assumes that either the antitrust authority doesn't see.
Actually, what I'm thinking is that if, say, the risk of being caught is not 20% instead of 30 or 50%, I wonder the incentive would actually differ between lower or higher power contract in terms of collusion.
Oh, sure. I think that basically determines the threshold for the contract. Yeah, absolutely.
Yeah. I was just thinking that now the result that you have is that high-powered contract does not necessarily incentivize the formation of collusion, but if the risk level is higher, I wonder if the result might change.
That's true, but in a sense, the interesting thing is that theoretically, the chat EU environment, you never need high-powered contracts. So if you set the probability of audits to be too high, you could break the environment in the sense that it makes it too so if I set P to be the probability of audit to be too high, I'll have to increase the high-powered the B parameter in order to make it incentive compatible to collude. If I raise P too much, then no one colludes ever.
Yeah.
So it's a calibration game in a way. But you're right. I think that would be a way to maybe lower all of these collusion frequencies would have been to choose a higher P, a higher probability of audit. Yeah. To be quite frank, when we were designing the experiments, we were sort of trading off. We didn't want P to be too low, because then no one gets audited ever. Yeah. And then you get this problem that Ju Young mentioned, which is this idea that I can never quit the cartel. So you just see a bunch of cartels that last forever. But if you set P to be too high, you could end up with situations where people are audited in 2 periods in a row. And that could, we didn't want that to happen with such short super games. Yeah. But I think the trick here is we had several dimensions to play with, and maybe this is a problem. I think you're right. I think this could be something to think about in a follow-up.
Thank you.
Yeah, I think if I add only one thing, there is a paper which said that on an average in the real life, detection rate is 15%. So I think your detection rate is not that low or high.
Oh, great. If you could send me that reference, if you find it, that would be amazing.
Yeah, I will send you, yes.
Thank you. Yeah, I think this is true for other environments that have these audit strategies. So if you look at the literature on tax evasion, you get all sorts of audit rates that may or may not be consistent with real life, but it's always an issue of making the treatment effect feasible. And I think we were, I don't know, maybe we should have been a bit more harsh to lower that that cartel formation rate, but you know, that's life.
So Miguel, thank you very much for your presentation. I think we enjoyed a lot. Yeah, that was really interesting. And thank you for everyone to come today. And I hope you enjoyed the presentation, and I hope you enjoy the rest of the day too.
Thank you very much, everyone, and I hope to see you soon.
Yeah. Thank you, Miguel.
Bye.